Bismillahirrahmanirrahim. Assalamu Alaikum, dear students. Welcome to my YouTube channel Learn with Azam. Today we will discuss about new syllabus National Book Foundation Physics SSC 2, Unit number 14, Current Electricity. Now we will discuss about SLO base according to FBISC requirement numerical problem. Today in this video we can solve question number 1 to 4 in part 1, remaining part in other videos. So let's move from question number 1. In question number 1, according to given statement, here, question number 1, 12 volt is applied on a copper conductor of the resistance of 6 kilo ohm. Find the current passes through it and how much the charge passes through it. Any cross-section area in 1 hour. Here, given statement, we can write the given data. So according to statement, given data, battery is attached of 12 volt. So voltage V is equal to 12 volt and resistance of conductor, that is R, 6 kilo ohm. Now R is equal to 6 kilo ohm. 1 kilo is equal to 10 raised to power 3. Here resistance R is equal to 6 multiplied by 10 raised to power 3 ohm and area of time is given that 1 hour. So time T is equal to 1 hour. 1 hour is equal to 3600 seconds. Now to find that current passes through it, current is equal to I is equal to question mark and how much charge. So charge is equal to Q, Q is equal to question mark. Now we using the formula according to the Ohm's law. V is equal to IR. We can find that R I, so this implies that I is equal to V upon R and also we can find that charge Q. Here Q is equal to IT. Now we will move the solution. Using the formula V is equal to IR according to Ohm's law. We can find that I, so R is divided on other side. This implies that I is equal to V upon R. Putting the values, then we have, this implies that I is equal to V upon R. Value of V is equal to 12 divided by value of R, 6 multiplied by 10 raised to power minus 3. 6 ones are 6, 6 twos are 12. So I is equal to 2 multiplied by 10 raised to power minus 3. 10 raised to power minus 3 is equal to milli. So given current is 2 milliamperes. So the SI unit of current is ampere. Here the given system of the current is 2 milliampere. Now we can find the charge. So now we have Q is equal to IT. Putting the value of I multiplied by T. So 2 multiplied by 10 raised to power minus 3 multiplied by 3600. Here multiplying this value we can find the charge Q is equal to 7.2 coulomb. Now we will solve the numerical problem 2. In numerical problem question number 2 is given statement. During the lighting 15,000 ampere current is established. When 40 coulomb current passes through a tree due to a potential difference of cloud and the ground of the voltage is 1000 volt. What is the direction of lighting bolt and find the power of lighting bolt. Now, according to the statement, we can write the given data. In given data, current I is equal to 15,000 ampere and charge Q is equal to 40 coulomb. Now, the voltage V is equal to 1000 volt. To find that power and also find the time, because here we can find the power of lighting and duration of lighting. So duration of lighting mean time and power of lighting mean P power. So using the formula according to the statement, P is equal to IV and we can find the time. So using the formula, Q is equal to IT. This implies that T is equal to Q upon I. Now we can find the solution using the formula to find the power. According to the formula, P is equal to IV. Now putting the values, I is equal to 15,000 ampere and V is equal to 1000 volt. Here multiply by 15,000 multiply by 1000. So the answer is 15,000,000,000 volt. Here we can move the decimal point from this point to this point. So here 6 zeros are given. So according to scientific notation is equal to P is equal to 15 multiplied by 10 raised to power 6 watt. Here 10 raised to power 6 is mega, then power is equal to 15 megawatt. Now we can find the time. So time T is equal to Q upon I. The value of Q is 40 coulomb divided by 15,000 ampere. 40 divided by 15,000 ampere, that is equal to 0.002667 seconds. Here decimal place move on forward, so 1 2 3 digits, then that is equal to 2.67 multiplied by 10 raised to power minus 3 seconds. So time is 2.67 multiplied by 10 raised to power minus 3 seconds. Now we will move the question number 3. In numerical problem, question number 3 given statement is the diameter of copper wire is 7.360 millimeter and find the resistance of a 5 kilometer length of such a wire using for the power station transmission. Here note is given that specific resistance of wire is 1.720 multiplied by 10 raised to power minus 8 ohm meter. So according to the given statement, we can write the given data. Given data is diameter D is equal to 7.360 millimeter. 1 millimeter is equal to 10 raised to power minus 3. So we can write that D is equal to 7.360 multiplied by 10 raised to power minus 3. We can write that diameter D is equal to 0.007360 meter. Now the length of wire is equal to L, that is equal to 5 kilometer. 1 kilo is equal to 10 raised to power 3. So 5 multiplied by 10 raised to power 3 is equal to 5000 meter. And according to the statement, given specific resistance rho is equal to 1.720 multiplied by 10 raised to power minus 8 ohm meter. Now we can find that the radius R and resistance R, capital R and area A. According to the statement, we can find only the resistance capital R and the area A. But we are required that the radius R also. So we can using the formula finding the radius. So according to the statement, diameter is given and radius is half of diameter. So we know that R is equal to D upon 2 and resistance of wire R is equal to rho L over A. Now we can find the area. Then area of wire using the formula A is equal to pi R square. So finding the solution, first of all we find the radius. Then R is equal to D upon 2. Putting the value of D, that is equal to 0.007360 divided by 2. Now dividing the value of D by 2, then R is equal to 0.00368 meter. Here radius R is equal to 0.00368 meter. Now we can find the area. According to the area A is equal to pi R square. Now we can find the area A is equal to pi R square. Pi is a constant value that is equal to 3.14 multiplied by 0.00368 whole square. Here the value of R square, radius square. So we can multiplying both values. The final answer of area is 4.25 multiplied by 10 raised to power minus 5 meter square. Now we can find the resistance. According to the statement, resistance R is equal to rho L over A. Putting the value of rho L over A, that is equal to value of rho is equal to 1.720 multiplied by 10 raised to power minus 8 and the value of length is 5 multiplied by 10 raised to power 3 and the value of area A is equal to 4.25 multiplied by 10 raised to power minus 5. Now we can solve this value, so the resistance is 2.02 ohm. Now we can solve the numerical problem question number 4. In question number 4, according to the given statement, here two resistors are given. So two resistors of 15 ohm and 75 ohm are connected in series. Here the value is connecting in series. If the voltage across is 15 ohm is 60 volt, the value of voltage of battery in a 15 ohm is 60 volt. What is the amount of current that can be passes through 75 ohm resistor? So we can calculate the value of current. According to the given statement, we can write the given data. Now, in given data, resistance R1 is equal to 15 ohm and resistor R2 that is equal to 75 ohm. Now we have the voltage V1 is equal to 60 ohm. Now here 60 volt is the voltage of the resistance R1 of 15 ohm. So we can write that V1. V1 is equal to 60 volt and now we can find the current passing through the 75 ohm. So now we can find the current from the resistor R1. Here the given statement is again read that both resistors are connecting in series. So first of all, we can find the current in a resistor R, then we can calculate the current in a resistor R2. So first of all, write the formula. According to Ohm's law, Ohm's law states that V is equal to IR. Here we can find the current, then we can rearrange these values. Now we have I1 is equal to V1 over R1. Here the value of V1 is equal to 60 divided by 15, that is equal to 4 ohm. So the current in a resistor R1, that is equal to 4 ampere. The value of current is I1 is equal to 4 ampere. Now we have find the current in R2. Here first of all we can read again and again both resistors are connected in a series. As a series, both resistors have a same current. So as current is remain as same in a resistor in R2 because both are connected in a series. According to the resistor or law, when resistors are connecting in a series, voltage is different, but value of current remain same. We can find only the value of amount of current. So as remain as same in a resistance connected in a series. So I1 is equal to I2, that is equal to I. Current cannot be changed, so I is equal to 4 ampere.